The 24th of September, 2025. For weeks, the astronomy community had tracked it. A strange interstellar visitor, designated 3I Phi Atlas, inbound from the direction of Sagittarius. Unlike typical comets, its spectrum defied expectations. Unlike Oumuamua, it carried a coma and tail, and unlike anything else before it, its motion betrayed bursts of energy that looked less like natural outgassing and more like deliberate maneuvering. Now, in the dead of night on Earth, but in the stark sunlight of Mars' orbit, Atlas did something no comet, asteroid, or interstellar rock had ever been seen to do. It triggered a shockwave. The first signs didn't come from optical telescopes. They came from radio instruments, not on Earth, but orbiting Mars. On the 24th of September at 2:19 UTC, the MAVEN spacecraft, orbiting high above the Martian atmosphere, recorded a sudden planet-wide disturbance in the ionosphere. Instruments designed to track solar storms registered a pulse of charged particles rippling outward from a point in space just millions of kilometers away, the exact sector where 3I Phi Atlas was passing. At nearly the same moment, the ExoMars Trace gas orbiter picked up a transient burst of plasma interference strong enough to garble communications for several seconds. Engineers first suspected a solar flare, but when they checked the solar monitoring satellites near Earth's SOHO South Dakota O. Parker solar probe, they showed nothing. The Sunday had been quiet. Dead quiet. The disturbance had come from near Mars itself. Within hours, the event reached Earth. The Deep Space Network antennas in Madrid and Canberra logged a faint, expanding ripple of charged particles washing through their sensors. Not a solar CME, not a coronal mass wave. This was something localized, as if a bomb had gone off in deep space. By dawn on Earth, independent confirmation arrived. The Mars Reconnaissance Orbiter detected unexpected dust lofting into the thin Martian air. Not weather, not a dust storm. Instead, a subtle compression, like the planet's upper atmosphere had been pressed and then released. Planetary scientists called it a shock front. But the real smoking gun came from orbital dynamics. Amateur astronomers, comparing tracking data, noticed that 3I Phi Atlas's path had shifted slightly. Not the gradual arc of a comet shedding mass, but a sudden, discrete change in velocity. For a brief window, it accelerated as if pushed outward by its own explosion, then settled back into its inbound trajectory toward the Sunday. The combined evidence: ionospheric disturbance, plasma burst trajectory shift, painted a single picture. Atlas had unleashed energy equivalent to a shockwave. How much energy? Estimates varied. Early models from the SETI Institute suggested a release on the order of 10 Phi joules, roughly the yield of the largest hydrogen bomb ever detonated on Earth, multiplied by 100, enough to rattle an entire planet's magnetosphere. And yet, strangely, Mars itself was unharmed. The wave had passed through without leaving a crater, without igniting the atmosphere, without triggering seismic aftershocks. It was not a physical impact. It was a pulse of energy through space, as if Atlas had fired a weapon or ignited a drive system far beyond human technology. Astronomers scrambled for answers. Was this natural? Could a comet do this? One theory: Atlas might have experienced a catastrophic outburst, a sudden venting of gas and dust from beneath its crust. Some comets undergo such events when volatile ices trapped for eons suddenly rupture. The most famous, Comet 17, P. Phi Holmes, brightened by a factor of 1,000,000 in 2007, blasting material into space. But Atlas was not a typical comet. Spectroscopy had already shown unusual chemistry: a nickel-rich spectrum with almost no iron, and a coma dominated by carbon dioxide instead of water. Even stranger, its earlier accelerations had occurred in stepwise pulses, almost like thruster burns. The timing also defied comet physics. Outbursts usually occur when a comet is heated by the Sunday. Atlas was still far from perihelion, farther from the Sunday than Earth's orbit, too cold for such violent venting, and the symmetry of the wave mattered. Holmes' outburst spread a diffuse cloud. Atlas event propagated like a perfect spherical shell, centered on the object, racing outward at thousands of kilometers per second. That's not venting. That's not gas dynamics. That looks like a controlled shockwave. Within 24 hours, space agencies went quiet. NASA, ESA, and Roscosmos all acknowledged an anomalous Martian ionospheric disturbance, but declined to link it to Atlas. Data requests from independent scientists were delayed. Public live feeds from MAVEN and MRO's plasma instruments were suddenly down for maintenance. But the amateur networks weren't silent. Bill Gray's Distributed Orbit Tracking Group noticed that Atlas orbital residuals, the tiny differences between predicted and observed positions, showed a clear impulse. The object had gained about 5 meters per second of velocity relative to predictions, small by spacecraft standards, but huge for a natural comet. Citizen radio astronomers also chimed in, using backyard dishes. Some reported a faint radio hiss sweeping past Earth hours after the shockwave. The frequency matched no known solar emission. Some swore they could see modulation, a hint of structure, almost like a signal buried in the noise. Forums lit up. Was Atlas a probe testing its propulsion? Was it a weapon demonstration? Or was the shockwave an accident? A containment failure of some exotic reactor? With officials stonewalling, the loudest voices were the amateurs, the podcasters, the fringe theorists, and then the comparisons began. Because Atlas wasn't alone. Across the inner solar system, another interstellar object, Cepheid 25R2 Swan, was making its own inbound dive. Swan was brighter, bigger, and stranger, with hints of a metallic hull, a plasma halo, and a staggering 22,000-year orbital period. If Atlas was the drone, Swan was the fortress. Both were inbound on near-synchronous perihelia. Both were passing through the critical October blackout window when the Sunday's glare blinded telescopes, and now, just weeks before that blackout, Atlas had fired something resembling a shockwave in Mars' backyard. Theories flourished. Was Atlas signaling Swan? Was the shockwave a beacon, a calibration pulse, a test before rendezvous, or was it a defensive action, warning off probes near Mars, sending a message to Earth? Toe cut through the noise. A coalition of independent observatories in Spain, Chile, and Australia pooled their data. They modeled the event's energetics. Their conclusion: the shockwave's effective yield was at least 3 Fe10 Fe-joules. That's nearly 1,000 times the energy of the Tunguska event in 1908, enough to flatten entire regions of Earth if it had been directed here. The spherical symmetry meant it wasn't a targeted strike, but the efficiency, the clean expansion, the uniform front suggested engineering. Nature is messy, engineering is precise, and then came the strangest data of all. High-speed photometry of Atlas coma showed not chaos, but order. In the minutes after the shockwave, the coma brightened in repeating bands, concentric ripples of luminosity, as if energy was being vented in phased bursts. Amateur astronomers overlaid the brightness curves, and they matched a mathematical pattern. Fibonacci spacing, coincidence or communication? Why near Mars? Why not Earth? Mars, unlike Earth, is a quiet planet, few satellites, little atmosphere, no magnetic shielding. If you wanted to test a high-energy pulse without interference, Mars orbit is a clean lab. But some weren't so sure. A declassified leak from the European Space Agency suggested the wave may have interacted with Mars's crust. Seismometers on NASA's InSight lander, still operational despite power issues, picked up a faint tremor coinciding with the event. Not from tectonics, but from a transient pressure wave traveling through the ground. In other words, the shockwave had coupled with the planet. A small effect, but measurable. Some speculated this wasn't a test at all, but a scan, a planetary ultrasound, probing Mars's interior, looking for something buried. Back in 2017, Oumuamua had baffled scientists with its acceleration. Some, like Harvard's Avi Loeb, suggested it might have been a probe, a light sail. Nudged by radiation pressure, the mainstream dismissed the idea. But Atlas was different. Atlas had gone further. Not a subtle drift, but a visible, measurable shockwave event. If Oumuamua was a scout, Atlas was the next step. a probe capable of releasing energy, steering itself, maybe even communicating. And Swan, still inbound, might be the mothership. One by one, the puzzle pieces clicked into a disturbing picture. 2017, Oumuamua Scouts. 2025, summer, Atlas arrives. Testing propulsion. 2025, autumn, Swan arrives. Massive and shielded. A sequence. An escalation. An audit chain. The timing couldn't be worse. From the 8th of October to 18th, 2025, Earth's telescopes would be blinded by the Sunday. The very days when Atlas and Swan reached perihelion would be unobservable from the ground. And now, just 2 weeks before that blackout, Atlas had announced itself with a shockwave near Mars. Governments tightened the silence. NASA locked down raw data from Mars orbiters. ESA scrubbed its public telemetry. Even amateur groups reported sudden outages, unexplained server failures. Some suspected hacking. Meanwhile, chatter on encrypted channels suggested the US Space Command had issued contingency plans for proximity response. No details leaked, but the implication was clear. Military planners were treating Atlas not as a comet, but as a potential threat asset. The story is still unfolding. At the time of writing, 3 Atlas continues its dive toward the Sunday, its coma reshaped by the aftermath.